Hello, hello, hello. Let us get started. So, hello, we are doing number 8.2, number twos. Now, 8.2 number 2 describes a rather unusual situation. Imagine you are in a beaker, an enormous tub, which is full of honey. Now the honey forms a crust at the top. So you're there, it's very dense, it makes you very buoyant, but the crust is preventing you from rising up. So basically you're there upside down in the honey, which makes you, well, happy because it's delicious, but perhaps sad because you can't breathe it. And so the question I have is, what would be the pressure on your ears? So, what is the pressure? Pressure equals what? Now, a couple things to think about. So, what do you need to know? Well, let's start out with a formula. Our formula for pressure, as written in the book, is equal to P, the pressure of the atmosphere, plus the pressure of whatever fluid you're in. In this case, it's honey. Honey, well, there's the density of the fluid times the force of gravity times your depth. In this case, your depth is your height. So, your height. So let's figure it out. Atmospheric pressure is 101 kilopascals, so it's actually 101,300 pascals. Now the reason I changed it from kilopascals to pascals is that this number, if you put everything in here, that's going to be in pascals. So you don't want to be adding kilopascals and pascals. Put them all in one unit or put them all in the other. So we're going to put them all in pascals. Plus, the density of honey is 1,420 kilograms per meter cubed. Gravity, Earthlings, is 9.8. And then times the height. Now my height is 1.9 meters. So we're off and running. Now, pressure here, this just goes down, 101,300 pascals, plus 1,420 or times, well, you multiply them together and you get 26,440 pascals. And then we add these together. And what I get is my final pressure, this is the pressure that you're going through, is equal to 127,740 pascals. Now, we do have limiting factors. One big limiting factor is that gravity has only got 2 sig figs. My height's actually 190 centimeters, so that's actually 3 sig figs. But the gravity is the limiting factor because gravity varies all over the planet. So does air pressure. But gravity varies all over the planet, so that's going to be our limiting thing. So that will limit us to 2 significant figures. So we're going to round this, and what I get is pressure, put it in the box now, pressure is equal to 130,000 pascals. Now, you could write it that way. Usually when people talk about pressure, they talk about kilopascals. So there's 1,000 pascals in a kilopascal. So you could also say the pressure is equal to 130 kilopascals. If you want, you can write it that way. Either way is fine. I would like to point out a few things. First off, number sense. You're probably not as tall as I am. Gravity is the same, density of honey is the same for everybody, but you're probably not as tall as I am. So that means that if you're upside down, your head's not going to be as deep, you're not going to be under as much pressure. Expect a number that's less than this. How much less? Well, this is the funny thing here. Look at the pressure that's due to the honey. 26,000 pascals. Pressure that's due to the air because the air is also pushing down, is 101. This is going to be the same for you as for everyone. Everybody's breathing the same air. But this is going to be less. But in the grand scheme of things, you would have to be a lot shorter than me to get enough of a difference here where, well, you get a difference here, you get a difference here, but enough of a difference where you'd round to a different number. You're probably going to end up, once you've rounded, with, if not this number, then something very, very, very close to it. Because the biggest source of pressure on your head is not the honey that's really, really dense. It's that ocean of air above you. Not very dense, but since you're so deep in the atmosphere, it adds up to more pressure than the honey. So what you get, we'll see. It's going to be less, but the question is, when you round it, will it be significant? Well, we'll find out.